Yo, what is up, guys? Welcome to another stream. So, this one is on factor investing. I have an assignment I gotta do for class that relates to the idea of constructing portfolios with different types of factors. So, I think I'm just gonna use this stream to kind of I'm gonna use this stream to complete my assignments, work through my assignments, and try to huh and try to what's it called, get some progress done. So let me, in the meantime, so I have two screens pulled up right now. Oh man, okay. Let's see if I can copy and paste all of these. Uh-oh. Okay, nice. So part B, analyze the returns and covariances by multiplying 12. Okay. I need some files for the actual assignment, so let me pull those up. So I have all the data, alright, and I just need to have the instructions 2 pulled up. So let's take a look here. Okay, so we need to work with, what is it? So analyze the returns. Okay, Python. Oops. So we have a Alright, so before we get started, I'm going to import a few things actually. So import numpy as p, import pandas as p, from pyplots, import from matplotlib, import pyplots as plt. Okay. So we have numpy. Alright. Now we could, so we can read in the CSV file. Alright, we'll call this and so industry returns. So industry returns df, call this pd.read CSV, and then we can just pass in our file in 30m evaluator returns.csv. Okay, display end turn data frame. Maybe I could do Quarto preview. Wait, CD homework 2, Quarto preview saying oh, okay, so we want to use maybe the index. So index is equal to, yeah, how to use unnamed column in CSV as index pandas. Okay, so index column is equal to 0. Let's see if this works. Nice. Oh wait, 20. How to turn index into dates. Maybe we could say df dot index is equal to date time dot index. Let's see, it's just gonna get some errors. Okay, yeah, it's gonna cause some errors. Oh. So I think this is maybe years. let's see, so 1926. It's almost 100 years, right? How date, time, object, numpy, dot, dot index dot apply. So we have lambda x, so we have x so we 0 to 5, 4 to 8 a frame, apply lambda. Lambda x. String manipulation data frame. Okay. How to insert character to string. Right, I feel like this is what I did, right? So what is this? F string invalid syntax? Maybe this has to do with it? Display. So I'm gonna just move this here just so I can see what's going on. Alright. Oh wait, maybe, let's see this. How to apply, how to apply function on pandas index. Next column is equal to 0, maybe. So let's see. Okay. So set data type of index. Read CSV. So maybe we could do dot index dot as type string. Let's see. Oh, nice. Okay, so it's actually through 4. All right. Type to string. Okay, so we have entered a kind of hyphen in between, and maybe we can now it's equal to pd dot to datetime df dot index. Nice. Okay, so I think now we actually have a date here. Okay. So add a hyphen to separate month and year. Change index to date time object. Okay. So the next question then is to then analyze the returns covariances by multiplying 12. Okay, so I guess they just so annual df is equal to df times 12. So just simply run it, display okay, display wow, so the beer industry returned really greatly. Maybe Prohibition ended somewhere around then? I don't know. I forgot when Prohibition actually started. Okay. And a single month in August. I guess that's good, right? Yeah. It could be cyclical, actually. Now that I'm thinking about it. 11. So this is August. Negative decline, actually. Wow. Okay. Okay, so in the next question, should we want to use, so analyze the returns, no, we want to draw the efficient frontier with 8 risky assets alone. So there's 8 industries we want to use, right? We want to use industries is equal to, there's 8 industries. I'm gonna look at smoke, fin, games. I'm not too sure. Fin is food, autos, books, electrical equipment. Returns annual select ALTF is equal to industry. Difference ALTF industries. Display sum. Index. Oh right, row column. Fin, coal, food, not index. Columns, display. Say what columns are there? Coal is in here. One, two, three, four, 5, 6, 7, 8. Alright, so there are 30 in there. Alright. How I just saw them. They were in display df dot columns. Oh man, okay. So I'm gonna need to maybe so how to strip column white space. Okay. I guess this is actually pretty nice. All right. Columns. Rename. Lambda x dot strip in place. Eliminates white space from column names. Nice, okay. So we have this, and then draw the efficient frontier without short selling. Right, I wonder if there's a way we can create a covariance matrix from all of these. So we can have the expected returns, right? All right, let's say expected returns is equal to industry dot mean, right? So let's display the expected returns. Okay, so expected annual returns. Wow, these are pretty high actually. All right, and then covariance matrix. So let's say covariance matrix data frame. Okay, so dot covariance display covariance matrix. All right. Okay, so we need to divide by 12. Alright. So there's a few things we actually need to do. So we need to select turn df is equal to divided by 100, right? So I think this can get us to a percentage form, and then we also want, so this will rescale data, but we also want the samples from, I believe, we want the data from 1996 to 2008 alone. So we have to select data from 1996 to 2008. All right. So with that being said, I think what we want then is we want to get our index. Yeah, I wonder how to get an index between two dates pandas. Okay, so let's see. '96 1 1 2 2008 1231. Okay, 1996 to, nice. All right, we have all of the data that we need. Okay, and this will give us all right, this should give us the entire thing. Okay, so now we have to draw the efficient frontier with 8 risky assets. Okay, I'm going to probably go use the bathroom for now. I'll come back in a sec. Okay, so we have expected. Alright, we have to create the efficient frontier. So we want to maybe label okay, so I think I might have to spend some time making a pretty little plot in Python. So I think what I could do here is maybe use some type of scatter plot. Okay, and then so fig x is equal to mat plt dot subplots. Okay. X dot plot. Let's see. Scatter plots. Python. Scatter So what's our X? Expected variance returns is equal to maybe we can do standard deviation. Expected deviation expected returns x dot set title efficient frontier constrained risk-free assets x dot set x label, so we call it standard deviation of returns, and then set y label. You have the expected returns. Okay, I see. How do we get the values of a data frame? Maybe we could do dot values. Oh shoot. I think this is what we need. So what if we deleted this? Okay. Alright, maybe is there a way to label dots in scatter plot Python? Annotates. Oh, I see. Okay. So x dot annotate text. Okay, so I think we can enumerate then. Alright, so for index text in string enumerates industries print index. Okay, nice. Alright, now we just need, okay, so we can do ax dot annotate industry. Maybe you could do offset is equal to 0.005 maybe. Okay, and then we could do ax dot annotate. So it has to be a tuple. Right, we could do maybe the expected returns. Actually, maybe we could just do this in industry plus offsets expected returns industry plus offset. Alright, so there's nothing. There is nothing here with print industry smoke fin, right? So not want to show up. If I just don't add the offsets. Nope. Okay, what is going on? Ax.annotate is not showing up. Oh, XY text maybe? So XY text is equal to XY. Text is equal to Oh, I think it's standard deviation actually. Right. There we go. Okay. Pluff plus offset. Pluff plus offset. Okay, that's good. Okay, so we have, this is all of the expected returns. Now we can create so this is plotting the mean returns of each industry. Okay, so that's what the expected returns are with respect to the standard deviation. Seems like coal is the industry with the highest volatility between the two years. Okay. You know what? Let me also make this a bit bigger. Fig size is equal to, let's do 12/8. Okay, maybe that's a little bit too big. 12/6. So we can maybe make this 10/6. Okay, maybe even less than that, 8/6. Okay. Alright, so with that being said, now we have to create our efficient frontier with just the risky assets, right? So how do we actually do that? Well, we have returns that we could, feasible returns. Right, so the feasible returns are going to be, I believe, so in order to actually, right, in order to compute the return on portfolio, it'll be the weights, vector of weights transposed. So the dot product between a vector of weights and a vector of standard and a vector of returns, then also plus vector of weights transpose. Okay, so how do we create this weight vector? Because we have a lot of possible combinations here between because each of these represents a portfolio with 100% weight in each of these different industries. then we would need to compute the weights. Let's say the coal as 1, then maybe coal is 99, smoke as 1%, autos as 1%, games as 1%, functional equipment as 1%, finished goods as 1%, food as 1%, books as 1%, right? How do we do that, man? Okay, this might be where I need to go look at the slides here. So let me sign in real quick. What the hell? Let me respond to this. Nice. Okay. Yes, this is my device. Alright, 443. What was I looking at? Alright, portfolio manage. Wait. How to construct a efficient frontier for portfolio of many assets. Let's see, ChatGPT. I feel like they should be able to help. How can I construct how would the weight distribution work? Oh, okay, so here's an idea actually, right? Now that I'm thinking about this, this is going to be the highest possible return for a given standard deviation, and this is the industry that will give us the lowest return. So the expected return on autos is the lowest, the expected return on coal is the highest. So when we draw our efficient frontier, really it connects these two. These are the 2 points where it kind of connects. Now, how do we incorporate the actually, let me see. How could I use Python to construct an efficient frontier of many assets? Wait, what is VStack? Yeah, this isn't really that helpful. VStack Python. So if the weights always sum up to 1, right? NumPy sum up to 1. How to make portfolio weights for many assets. Stack Overflow. Okay, maybe I could do random weights. Okay, yeah. So I think maybe an interesting way to go about this is we can just use random weights. MP dot, so I think that's MP dot random dot seed 0. All right. Random generator. So we have n by that'll be 8s 500. So random weights normalized random weights is equal to random weights divided by random dot sum, and then we can do access. Wait, actually, yeah. Column. Okay. I feel like this would probably, okay. So you with a 0 for column. All right. Bump this up to 500 maybe. Okay. So, and then we could say for so combined portfolio expected return is equal to random weights normalized random weights we have unexpected returns. Transpose maybe. 8s. Combined portfolio standard deviation is equal to T, so it'll be 500 by 8. I think times covariance matrix times normalized random weights T. So, and then we could maybe plot x dot plot combined portfolio standard deviation and combined portfolio expected return. I'm curious to see what this looks like now. Okay, yeah, this is not good. Oh man, okay. Yeah, I think maybe I need to actually go through for normal, for weights, and normalize random weights. By print weight. Let's see this. Yeah, these weights are really small actually, so how to normalize rows. Let's see. How to normalize rows in a data frame. div numpy array divide column. Divided by what the. So I'm gonna add this Stack Overflow post to help with this. Okay, let me see though. All right, still nothing though. I think this is probably. Square root. Alright. Still nothing. Shoot. Oh, that's why. Okay. Got append. So the reason why I'm getting this error is because I forgot to actually turn these into a list. Alright, so it's still getting this weird thing. Not as smooth. Yeah, this might be something I need to ask in class, because I'm a bit confused on how we can do that. Yeah, I'm not too sure, so I'm gonna probably take a break for now, go skate a little bit, think about the problem, and then come back to it later. I still have a bit of time before this is due, but I also need to spend some time today thinking about what I need to get done the next 2 weeks, because I have a few exams coming up and also a few assignments due this week and the next. So I need to get that kind of sorted out together. Alright, in the meantime, I'll probably end the stream here and see you guys in the next one.